Alright, welcome students to your third virtual clinic with me. Okay, for this time, I've decided that, you know what, let's revise on our circuit diagrams. Okay, now, this is a topic that most classes, actually all, have recently learned. We've started this topic 2 weeks ago, so I realized that okay, this is the topic that we really need to revise because many of you are still very weak in this topic. Okay, so please get yourself ready. Go and grab all your stationeries needed. Anything to make colorful notes. You can even use your own exercise book to write the notes in, or even a different exercise book. Up to you. Okay, go and get yourself ready. Once you're ready, you can continue with the video. If not, pause this video, go grab all your things, and play it back later on. Okay, for those who are ready, let's go. Okay, the objectives for today's lesson is number one, students would be able to identify at least three conventional symbols. Okay, now you'll be wondering, teacher, what does it mean by conventional symbols? Okay, conventional symbols mean drawn symbols. Okay, in a circuit, usually wires are curvy. Okay, imagine this as a light bulb. Okay, just a light bulb. I'm mirroring also. Okay, I mean, you're supposed to have a switch as well together with batteries, but this is just an example. All right, the wires in real life is curvy, but in actual circuit drawing, you are supposed to draw straight lines to represent these wires. Usually, people draw rectangles, okay, to represent a circuit. So this is how it should be, okay, along with the bulb logo. Okay, so anyone has a clue of what the bulb logo looks like? Okay, we'll get to know in a bit. All right, the next symbol will be students will be able to describe how a circuit works. Okay, now, how does a circuit works in terms of where the power is coming, how is the components of the circuit is working, and what kind of energy it uses, what kind of energy it translates to. So all of this is very necessary in this topic. Okay, last but not least, you'll be able to predict results from various changes of components in a circuit. So you'll be able to predict results. For example, if I were to initially only give you one light bulb, then I were to add another light bulb, so you'll have two. However, if one light bulb not working, what will happen to the other light bulb in a series circuit? So you must be able to understand how a series circuit works, as well as what is the consequences if certain situations varies. Okay, all right. So if you guys are ready, here's where we actually will begin. Let's go. Okay, before we begin, I want to just try it out with you. Okay, I want you all to take 1 minute to try to guess what does this symbol represent. All these three. Okay, all these three symbols represent. Okay, I will put a timer here. Okay, I'll put a timer here. My 1 minute clock begins now. Okay, time is up. All right. So this symbol represent. Okay, the first one, the straight line. Okay, the straight line, as I mentioned before, it represents a wire. Okay, very good for those who got it correct. Very good. What about this one? This weird circle with a cross in it. It doesn't even look like any of the components, but actually it's a lamp or a light bulb. Okay, in exam, you can either answer lamp, you can either answer light bulb, or you can just say bulb. All three are accepted. Okay. What about this? I think this is pretty simple. It already gives you a big clue. It starts with the letter M. So it's a motor. It's the motor. Okay, now let's go into our real notes today. Okay, number one, I want everyone to get this correct. Circuit diagrams are drawn with conventional symbols to represent the components of a circuit. Why? Why? Because you can't be drawing 3D circuits every time you do an experiment. That is why scientists have come up with the idea to just draw symbols instead, and they have made it standardized in terms of like every people on earth would actually use these symbols to represent circuits. So they've come up with a list of circuits. Let's talk about each of them. Okay, let's go. All right, first and foremost, it's the battery. Okay, you can either say battery or cell, no problem. Okay, you can put a battery or cell. Okay, so now usually, batteries, of course, they provide energy, but what type of energy? Electrical energy. They are represented with a one long line and one short line. This is to represent the both positive and negative sides of the battery. Okay, so the one long line and one short line is to represent one positive and one negative side of the battery. Yeah. Right. So far, so good. Can I proceed? Okay, very good. Let me just delete this. Okay, let's go. The second one would be a very simple one, which is the wire. Okay, don't forget, again, I remind you, in real life, wires are curvy. Okay, wires are curvy. But in drawings, we're supposed to draw a straight line. Exactly. Wait, let me. You're supposed to draw a straight line. Okay? All right, this wire is actually to allow current to travel. What type of current? Electrical current, right? It allows electrical current to travel. That means from one point to the other point, electricity is carried out through these wires, right? Okay, let's go on to the third component. The third component would be the lamp or the light bulb. Okay, the lamp or the light bulb. Okay, as I said now, you can say lamp, you can say light bulb, you can say bulb. Okay, but you cannot say light. It doesn't make sense. All right. The function is to convert electrical energy into heat and light energy. Okay, so it is represented with a circle and an X. Okay, you'll be wondering, teacher, why does it have to be represented by an X? Okay, this is because it differentiates between it and another component, which is the motor. So we can't be just drawing a circle. It wouldn't much differentiate. So scientists have come up with the concept of putting a cross inside of it to represent highly of how the light bulb looks like. Okay. All right. You ready? Let's go on to our fourth component. Okay, our fourth component is the motor. Okay, the motor converts electrical energy into movement energy. Okay, so what does the motor do? Okay, the motor makes sure, okay, it makes sure that energy continues flow in the circuit. Okay, without the motor, okay, we wouldn't have a continuous electrical current. Okay, with batteries alone, you see, batteries, they are not able to partition energy so that we will be able to save them and to last the energy. However, for motors, they are able to continue generating more and more electricity because they have already partitioned the energy. Okay, are you ready to go on to the next one? I think we have one more left. The switch. All right. The switch, of course, by the word itself, the switch is to on and off. Okay. Is to on or off the circuit. Okay. And off the circuit. Okay. The reason being is the function is to allow the circuit to be open or closed. Okay. It is represented with two circles and a line because it looks exactly like this in real life. However, try to guess what type of switch is this? Is this an open switch or a closed switch? Exactly. This is the open switch. Okay. You'll be wondering, teacher, how to know if a circuit is open or closed? Okay. If, let's say, in your circuit, let's say this is your circuit, right? Okay, we just put a very simple circuit. One light bulb. This is the realistic drawing, not the circuit drawing. One light bulb. Okay. And then a switch. Let's say lah. A battery, and then my battery can also, and the switch. Okay, the switch will look like got two stand, and then got this one blade, and then got one platform. Okay, it will look like this. Okay, now, if let's say the switch is up and it's not connected to the other part, which is, okay, the switch must be going down. It must connect down. So if it connects down, then it's called a closed circuit. However, if it's left up, it's an open circuit. So in summary, open circuit means circuit is off or not working. Okay. Closed circuit means circuit is on or is working. Right? Okay. So this is the definition for each of the different type of circuits. Right? Are you ready to go on to the next part? Okay, let's go. Oh, I forgot. We have one more component. Okay, the component is the buzzer. Okay, the buzzer converts electrical energy into sound energy. You'll be wondering, teacher, what is a buzzer? Okay, now have you all, okay, an example would be a doorbell. That is the most simple example. A doorbell is a very classic example of a buzzer that we use in most of our homes. Okay? The buzzer will look like a button in which that if you press on the button, it will make sound. Okay? All right. I'm ready to go on to the next part. Okay, so basically this is the summary for the entire thing. Okay, you can take a screenshot of this for your own reference. Okay, the battery or the cell, okay, or you can say the cell is represented with a symbol of one positive and one negative side, and it provides electrical energy. Okay, the wire which allows current to travel. Okay, we want to teach you what's current. Electrical current. Okay, electrical current to travel. Okay. All right. For the bulb or the light, okay, you can actually it's not really correct. This one I would change this. The bulb or lamp or light bulb. Okay, converts electrical energy into heat and light. Okay, the motor, which is represented with a big M in a circle, it converts electrical energy into movement energy. All right. Switch that is represented with two circles in one straight line. Okay, it allows circle to be opened or closed. The buzzer, it converts electrical energy into sound energy. All right, I'll give you a few seconds for you to take a screenshot on this if you need. Okay, let's go. Let me clear this up. Let's go into some questions. This is my favorite part. Okay, what do you think this symbol is for this component? Okay, I'll put a 1 minute timer. All right, I'll put 1 minute timer. Let's go. Okay, time is up. The answer is this is represented with one short and one long line. Okay, are you ready for the next question? Okay, what do you think this component is represented in symbol? Okay, let me put a timer again. Okay, time is up. The answer is represented with just a one straight line. Okay, do you want one more question? Let's try one more, shall we? Okay, last one. What is the symbol for this component? Okay, I'll put a 1 minute timer. Let's go. Right, time is up. Okay, the answer is it is represented with a circle and a cross in the middle. Okay, let's go on to our next part of the virtual clinic. Okay, now before we begin, I want to start off with a question. What do you think? Okay, since you've already learned the parts of each of these components and their symbols, okay, can you draw out the circuit diagram for this circuit using the conventional symbols? Okay, draw it in a piece of paper. I'll give you 1 minute, then you can check your answers. Okay, let's check the answer. This is the answer. Okay, for those who got this correct, I am so proud of you. You have already understood the most important thing that I've wanted to deliver today. Okay, let's finish up our virtual clinic with a bit more knowledge to add on. Okay, now I've already talked about what is a conductor and what is an insulator, right? Okay, a conductor is basically any material that does conduct electricity. See here, which makes the light bulb light up. Okay, so basically, what does conduct mean? Okay, conduct mean allow electricity to pass through them. This is what conduct means. Okay, it allows electricity to pass through them. Okay, so examples of conductor would be like metal, any other materials that can conduct electricity. For example, like metal spoon, paper clips, and all that. Okay, another the opposite of conductor are insulator. Okay, insulators are materials that does not conduct electricity, in which they will not let the light bulb on, okay, because they cannot allow electricity to pass through them. Okay, so speaking of which, let's talk about it more in detail. Okay, conductors are materials that does conduct electricity, namely metal spoon, paper clip. Okay, so the examples would range from metal spoon, paper clip, what else? Nails, thumbtacks, um, tags, coins. Okay, so these are the example of materials that will allow electricity to pass through them. Okay, so the opposite of conductors are what? Insulators. Very good. So insulators are basically any material that does not conduct electricity. For example, in this case, we have, okay, example, sorry, plastic, a rubber duck, gloves, book or paper. Okay. Right, these are the examples. There are many more actually, but these are just the very most common examples that people usually give, and I would give also to my students. Okay, so far so good with the whole conductor and insulator. Okay, very good. This is just the added knowledge I want you all to learn. Okay, question time. One last question before we end. Okay, draw a circuit diagram with one bulb, three cells, and one switch. Okay, I'll put 1 minute timer over here. I want you to draw it in a piece of paper or your notebook. Okay, then you can check the answers. Let's go. Okay, so the answer is ta-da! It will look like this, okay? Two cells, two bulbs, and one switch. Okay, you can on and off the switch, no problem actually. You can leave it on or you can leave it off, no problem. Okay, so it's correct. Okay, now, very good. Okay, so we are at the end of our virtual clinic today. Thank you very much for participating and listening until to the very end. I'm very, very proud of all of you. Okay, don't forget if you have any questions at any point, you can always email me at yvonne@sjis.edu.my. Okay, you can always email me at any point, but make sure your emails are always school related matter. Okay, thank you very much, class. I'll see you very, very soon in your class. Take care. Bye.